Now we move on to Fischer projections, and these are two-dimensional representations of carbohydrates that allow us to easily visualize the differences in the enantiomers of carbohydrates. In these drawings, horizontal lines will represent bonds that project forward to your face, and vertical lines will represent bonds that project backward away from you or behind the plane of whatever you're looking at. If it's a piece of paper, behind the paper, or if it's a screen like you're going to look at on this video, it would be behind the screen. So I've got the same molecule here drawn in three different ways. It is L-erythrose, which is, again, a sugar. And the one on the left is the typical Fischer projection. And that, as I mentioned on the previous slide, the horizontal lines, which I'll highlight in green, these there, represent bonds that project forward towards your face. But the vertical lines, which I'll highlight in yellow, represent bonds that are projecting backwards. And so if you were to take the molecule here and kind of spin it around this way, so you were to get a side view of it, the hydrogen and hydroxyl groups here would be on the left. Okay, and so you can see, since this carbon is in a vertical line with this carbon, it's essentially behind it, as you can see right there. And then between these two carbons, it's in this way above it, but if you were to, let me see if I can do this. If I was to take this molecule and move it over here, just out of the way, and I rotated it, you can see that it would be behind it in a sense. So it is behind it, okay? And then looking at this carbon and the bond there, that's the blue carbon is definitely behind it, and so on and so forth. So that's exactly what is going on with these Fischer projections. So overall, you should be able to look at this right here and understand what it actually looks like in, I guess, 3 dimensions. It's a way of simplifying that process. There we go, so we got rid of all that. So again, you should be able to connect that drawing to this one over here. One more thing that's actually not directly put into the slide is this L, what the L means there for the erythrose. The L indicates what side of the molecule in the Fischer projection the last alcohol is on. And so that means this blue one here. Since it's on the left side of the drawing, we have L-erythrose. If we had another molecule, which if I draw it like this, and the alcohol is on the right there, and I'm going to, sorry about this, but we've got the alcohol at the second to last position right here. In that case, this would be D-erythrose, not R. And D just comes from the word, or really the Greek word dexios, which means right-handed or skillful. Our common word, or I mean, our modern word dexterity comes from that as well. All right. So D for dexterous for right-handed. So example 3 here, identify each of the following as the D or L isomer. And so again, all we do is look at the penultimate carbon atom's alcohol. And so in part A, we have the alcohol right here. It's on the left. And so this would be L isomer. We can just call it that. And then in the other one, the penultimate carbon, which is right there, has the alcohol on the right. So this would be the D isomer. Example 4, draw and name the Fischer projection for the mirror image of ribulose. And ribulose is actually going to look like this. Okay. And what I've done is I drew in there in the first place the answer to this question, the mirror image of it. Okay, so this is ribulose, and the mirror image of it is right there. So what we can see is the penultimate carbon in the mirror image of ribulose has the alcohol on the left, so this would be L ribulose. And just regular ribulose, probably the predominant form of it is D ribulose.